So this video is going to be focused on solutions and the formation of solutions and a calculation called molarity. And I will also put another link up for another video. So what my notes are showing here is how does an ionic salt dissolve? And so one of the questions that chemists have is how does that process happen? So I showed you in the previous video with water that we usually write the ionic salt and then we write water above the arrow and then we have the two ions on the other side. So what I want to emphasize when you are doing this is the fact that the cation is going to be surrounded by the oxygen and the nitrate or the negative anion is going to be surrounded by the hydrogen ends. And of course, in this picture, you have far more water molecules than you do the corresponding cation and anion. The second example I have in my notes is sodium carbonate. And what I want to show you with this is in the beaker itself, you need to show me that there are 2 sodiums for every 1 carbonate. So the surrounding of it does not matter. And sometimes you guys ask, how many waters do you have around it? That's irrelevant to how you draw it. Instead, I'm looking for do you have the oxygens pointing and the hydrogens pointing towards the appropriate anion or cation. But in the beaker itself, I would want to see 2 sodiums and 1 carbonate. So we are going to be looking at solutions in terms of what we call concentration. And the other video I'm going to link up goes through this example. And Ms. G also made a slide to go through this calculation specifically. So this is kind of a backup if you need to hear my voice kind of explain things. So molarity is going to be the go-to for most chemists in terms of how much stuff, how much solute do you have dissolved. So molarity is going to be a capital M, and you might have noticed that in some of the labs we've done. Moles of solute over liters of solution. Now realize liter of solution means the solute and the solvent. And we are not going to focus too much on the calculation on that part, but instead I want you to know it's moles over liters. You could use that as your unit or you could use a capital M. So one of the solutions that is made is something called copper 2 sulfate pentahydrate. This is called a hydrate. Reason it's called a hydrate is because there's 5 water molecules attached to the crystal structure. You don't need to know that. But these are kind of cool solutions because they do have color. This one in particular is a blue color. So what you're trying to figure out is what is the molarity if I have 125 grams into 3,400 milliliters of solution. So what you have to do first is convert the grams to moles. And what you have to recognize is if I add up a copper, a sulfur, and 4 oxygens, I get around 159.6. But I have an additional 5 water molecules. And whenever you have a hydrate, it is a plus sign. That little dot there means it's attached, but it doesn't mean multiplication. So what I'm going to do is take the molar mass of water, which is 18, and multiply it by 5. So my total molar mass is 249. So what I set up here is, again, our moles. 125 grams is to X moles as the molar mass is to 1 mole. I get 0.5. And then I convert my milliliters to liters by moving the decimal 3 over. So that's how I get 0.5 over 3.4, which is 0.15 molarity.